The Leaning Tower of Pisa is famous. It's famous for its tilt, which has fascinated people for centuries. The tower started leaning while it was being built, which was quite unexpected. Construction began in 1173, during a time when engineering was still developing. The ground under the tower was soft, consisting of clay, sand, and shells. This caused the foundation to be unstable, leading to the initial tilt. The tower started to lean before the third floor was finished, alarming the builders. Builders tried to fix the lean by making adjustments during construction. They made the columns and arches taller on one side, hoping to correct the tilt. This made the tower curved, giving it a unique and distinctive shape. But it didn't stop the leaning, which continued to worsen over time. The tower is made of heavy marble, adding to the stress on its foundation. Over the centuries, the weight of the tower made the lean get worse, becoming more pronounced. By the 1990s, the tower was leaning dangerously, posing a serious risk. It was tilting by 5.5 degrees, a significant angle that worried many. Experts worried it might fall over, leading to a potential disaster. They knew something had to be done, and quickly, to preserve this iconic structure. In 1990, a committee of experts began studying the tower. The Leaning Tower of Pisa had been tilting more and more each year, and there was a real fear that it might collapse. They wanted to find a way to save it. The challenge was immense, as they needed to preserve the historical integrity of the structure while ensuring its safety. They drilled holes in the ground to study the soil. Understanding the composition and behavior of the soil was crucial to developing a viable solution. They built models of the tower. These scale models allowed them to test various stabilization techniques without risking damage to the actual tower. They used computers to simulate different solutions. Advanced computer models helped them predict how the tower would respond to various interventions. The experts decided on a temporary solution. This would buy them the time needed to develop a more permanent fix. They added lead counterweights to the north side of the tower. These weights were carefully calculated to counteract the lean. These weights were like giant balancing blocks. They provided the necessary counterforce to prevent further tilting. The weights helped to stabilize the tower. This temporary measure was a crucial step in the preservation process. They bought the engineers some time to find a permanent fix. The race against time continued, but the immediate danger had been averted. The engineers considered many potential solutions. One idea was to pump water out of the ground to stabilize the soil. They thought this might make the soil under the tower firmer and more stable, but they were worried about changing the groundwater levels too drastically. It could have made the problem even worse. Another idea was to use a technique called electroosmosis to address the issue. This involves passing an electrical current through the soil to move water. The idea was to move water away from the foundation and improve stability, but the soil under the tower wasn't suitable for this method either. Finally, after countless hours of brainstorming and numerous failed attempts, the engineers came up with a solution that worked. They decided to remove small amounts of soil from under the north side of the tower, a delicate and precise operation. This careful removal would allow the tower to settle back into a more upright position, gradually correcting its famous lean. They called this innovative process under-excavation, a technique that required both precision and patience. The engineers started by drilling small holes under the foundation, ensuring each hole was strategically placed. Then they carefully removed soil bit by bit to avoid destabilizing the structure. They used special equipment to make sure they didn't remove too much, maintaining a delicate balance. Slowly, the tower began to straighten, a testament to the engineers' skill and precision. It was like magic, but it was really engineering. The culmination of hard work and innovative thinking. The under-excavation was a success, a groundbreaking achievement in the field of structural engineering. The tower's lean was reduced by 0.5 degree, a small but significant change. It was enough to make it safe, ensuring the tower would stand for many more years to come, and they decided to keep a little bit of the lean, preserving its iconic character. After all, it's what makes the Leaning Tower of Pisa so unique, drawing millions of visitors from around the world.